Finding the other unknown terms in an arithmetic sequence. Arithmetic sequence. The general rule of an arithmetic sequence is given by a sub n equals a sub 1 plus the quantity of n minus 1 times d, where our a sub n is equal to the nth term, a sub 1 is the first term, n is the number of terms, and d is the common difference. Let us now derive the formulas in finding the other unknown terms given arithmetic sequence. Again, the general rule will be a sub n equals a sub 1 plus the quantity of n minus 1 times d. If we are looking for a sub 1 or the first term, we use this general rule of an arithmetic sequence. And then we apply addition property of equality or APE. We add negative quantity of n minus 1 times t to the whole equation. That is, a sub n plus negative quantity of n minus 1 times d is equal to a sub n minus the quantity of n minus 1 times d. A sub 1 plus the quantity of n minus 1 times d plus negative n minus 1 times d, it will be cancelled, so the remaining is a sub 1. Therefore, the formula in finding a sub 1 will be a sub 1 equals a sub n minus the quantity of n minus 1 times d. If we are looking for d or common difference, we use again the general rule of an arithmetic sequence. And then we apply addition property of equality or APE. We add negative a sub 1 both sides. A sub n plus negative a sub 1 is equal to a sub n minus a sub 1. A sub 1 plus the quantity of n minus 1 times d plus negative a sub 1. Our a sub 1 will be cancelled, so the remaining will be n minus 1 times d. We need to eliminate n minus 1 besides d. That is why we apply multiplication property of equality or MPE. We multiply this whole equation by 1 over n minus 1. A sub n minus a sub 1 times 1 over n minus 1 is equal to a sub n minus a sub 1 over n minus 1. N minus 1 times d multiplied by 1 over n minus 1, our n minus 1 will be cancelled, so the remaining will be d. Therefore, the formula in finding the common difference or d is a sub n minus a sub 1 over n minus 1. Or, if the first term is not given, we can have a sub k in replacement of a sub 1 and k instead of 1. Or that would be a sub n minus a sub k over n minus k is equal to d. If we are looking for n or the number of terms, again we use the general rule of an arithmetic sequence. And then we apply addition property of equality or APE. We add negative a sub 1 both sides. A sub n plus negative a sub 1 is equal to a sub n minus a sub 1. A sub 1 plus the quantity of n minus 1 times d plus negative a sub 1, it will be cancelled. The remaining will be n minus 1 times d. We need to eliminate d besides n minus 1. So we apply multiplication property of equality or MPE. We multiply this whole equation by 1 over d. That is, a sub n minus a sub 1 times 1 over d is equal to a sub n minus a sub 1 over d. N minus 1 times d times 1 over d, our d will be cancelled, so the remaining is n minus 1. Negative 1 must be eliminated here so that we can only have here n. That is why we apply again addition property of equality or APE. We add both sides positive 1. So a sub n minus a sub 1 over d plus 1 is equal to a sub n minus a sub 1 over d plus 1. And n minus 1 plus 1, our 1 will be cancelled, so it will be equal to n. Therefore, the formula in finding n will be a sub n minus a sub 1 over d plus 1. Let us now apply the given formulas in finding or solving problems. Example number 1. In the arithmetic sequence 4, 7, 10, 13, and so on, which term has a value of 301? The given are, the first term or a sub 1 is 4. Our d is 7 minus 4, 10 minus 7, 13 minus 10, which is equal to 3. And our a sub n or last term would be equal to 301. The unknown here is n, or the number of term. Which term has a value of 301? To solve this, we use the formula a sub n equals a sub 1 plus the quantity of n minus 1 times d. Or in the derived formula, that is n equals the quantity of a sub n minus a sub 1 over d plus 1. Now to solve that, we substitute the given values. So we have n equals, our a sub n is 301 minus our a sub 1 is 4 over the common difference 3 plus 1. Simplifying this, 301 minus 4 is 297 over 3 plus 1. 297 divided by 3 is 99 plus 1 is equal to 100. Therefore, 301 is the 100th term in the given sequence 4, 7, 10, 13, and so on. Example number 2. Let us find the first term and the common difference of the given arithmetic sequence with a sub 4 equals 10 and a sub 11, which is equal to 45. The given here are the a sub 4 and the a sub 11, which are equal to 10 and 45 respectively. What we need to find are the first term, or the a sub 1, and the common difference, or d. Now to find this, we use the general rule a sub n equals a sub 1 plus the quantity of n minus 1 times d, or the derived formula for d, which is a sub n minus a sub 1 over n minus 1. But since the first term is also unknown here, we use a sub k instead of a sub 1 and k instead of 1. That is a sub n minus a sub k over n minus k. Let us now solve this. First, we need to find for the first term, or a sub 1. We need to create two equations using the given terms. So we have first a sub 4 equals a sub 1 plus, we have n minus 1 times d, our n refers to 4, minus 1 times d. Simplifying this, 4 minus 1 is equal to 3d. And a while ago, in our given, a sub 4 is equal to 10. Therefore, the first equation is 10 equals a sub 1 plus 3d. And for the second equation, we have a sub 11 equals a sub 1 plus, our n is 11 minus 1 times d. Simplifying this again, 11 minus 1 will be equal to 10 times d is 10d. And a while ago, our a sub 11 is said to be equal to 45. So the second equation will be 45 equals a sub 1 plus 10d. So we use these two equations. We solve these two equations simultaneously by subtracting the equations. We have 10 equals a sub 1 plus 3d, and 45 equals a sub 1 plus 10d. Remember, in subtracting, we change the sign of the subtrahend and then we proceed to addition. So between these two equations, this equation 45 equals a sub 1 plus 10d will be the subtrahend. We will change the signs. So 45 becomes negative 45, a sub 1 becomes negative a sub 1, and 10d becomes negative 10d. And then from subtraction, we'll proceed to addition. So 10 plus negative 45, a sub 1 plus negative a sub 1, 3d plus negative 10d. So 10 plus negative 45 is equal to negative 35. Our a sub 1 will be cancelled. And then 3d plus negative 10d is equal to negative 7d. We need to eliminate negative 7 besides d. That's why we apply MTE. We multiply the whole equation by negative 1 over 7. Negative 35 times negative 1 over 7 will be equal to 5. And then negative 7d times negative 1 over 7, it will be cancelled. The remaining is d. Therefore, the common difference here is positive 5. So since we have solved the value of common difference or d, which is 5, we can now solve for a sub 1 using any of the two created equations. So first we use a sub 4. Remember, our a sub 4 a while ago is equal to a sub 1 plus 4 minus 1. Then we substitute our d, 5. Simplifying this, 4 minus 1 is equal to 3 times 5 is equal to 15. And then our a sub 4 in the given is equal to 10. Therefore, we have 10 equals a sub 1 plus 15. And then to find for a sub 1, we apply addition property of equality or APE. We add both sides negative 15. So a sub 1 plus 15 plus negative 15, the 15 will be cancelled. And then 10 plus negative 15 will have negative 15 plus 10. Negative 15 plus 10 is equal to negative 5. So using a sub 4, our a sub 1 is equal to negative 5. Let's use the other equation. A sub 11. A sub 11 is equal to a sub 1 plus 11 minus 1 times d. Our d again is 5. 11 minus 1 is 10 times 5. That would be equal to 50. And our a sub 11 a while ago is equal to 45. We apply APE or addition property of equality. We add negative 50 both sides to eliminate this 50 besides a sub 1. 45 plus negative 50 or negative 50 plus 45 is equal to negative 5. A sub 1 plus 50 plus negative 50, the 50 will be cancelled, so the remaining is a sub 1. Therefore, using a sub 11, our a sub 1 is still equal to negative 5. So the first term of the given sequence is negative 5. Let us have example number 3. Find a sub 1 if a sub 8 is equal to 54 and a sub 9 is equal to 60. What are the given? A sub 8 is equal to 54, a sub 9 is equal to 60, and the common difference can be obtained by subtracting any two consecutive numbers. Since the given are a sub 8 and the a sub 9, we can now subtract these two numbers. That's why we have 60 minus 54 is equal to 6. What do we need to find? So we need to find for the a sub 1 or the first term. Now to find the first term, we need to use the general rule of an arithmetic sequence. That is, a sub n equals a sub 1 plus the quantity of n minus 1 times d. Or, it can be a sub 1 is equal to a sub n minus the quantity of n minus 1 times d. So now, let us solve. By substitution, we have a sub 1 equals our a sub n refers to the a sub 9. That would be our last term here. So that is 60 minus our n. Since we have a sub 9, our n here becomes 9. Minus 1 times our d or common difference is equal to 6. To solve this one, we need to simplify first 9 minus 1 times 6 using the PEMDAS. So we have to subtract 9 and 1, that is 9 minus 1 is equal to 8 times 6 is equal to 48. So we have 60 minus 48 is equal to 12. Therefore, the first term of the given sequence is 12.